Okay. Hello, everyone. Welcome to this talk. Today, we're not going to talk about Google Glasses, so you're in the wrong room if you want to talk about this. We'll talk about mostly code around Hadoop MapReduce. We'll talk about the French railroad company. We'll talk about Pig, Hive Cascading, and last but not least, we'll talk about the future, which is exciting. First of all, let's introduce ourselves. I'm Pablo Lopez. As my crappy accent may say, I'm not Spanish, but French. I work for Xibia, French Java and Agile-centered software company. Xibia has an older sister in the Netherlands. Maybe there is some Xibians here? No? No one? Okay. I will host this talk with Bertrand Dechoux.
So, hi. My name is Bertrand Dechoux. So I started using Hadoop at the beginning of 2010. So back then I was an employee of a startup and we were building a kind of a web search engine, so crawling the web, storing web pages into Hadoop and analyzing Hadoop. Now I am part of the Apache Hadoop community as a committer to the MR unit project, which is a project to easily test MR MapReduce jobs. And professionally, I am a consultant and a trainer on Hadoop for Xibia. And yeah, so I've been helping a big French transport company make sense of Hadoop, and that's what we will talk about today.
So the story begins in the late 2009. I was working for the front website of the French railroad company, which is called voyagesncf.com. Did some of you came by Thales? Here? Ah, yeah. So you probably don't know, but you probably went buying your tickets on Voyage SNCF or one of the blank marks it used. Voyage SNCF sells roughly about half train tickets in France, but also lots of train tickets in Europe, Thalys, Eurostar, and so on. So this is one of the most visited European websites, and with a huge amount of traffic comes huge infrastructure. This infrastructure generates lots and lots of logs in a wide variety of formats. And in 2009, those logs just piled up, never being looked at. And it was a problem because, as we now know, there is really valuable information in those logs. So we wanted to use them. We started an Hadoop project. Why an Hadoop project? Voyage SNCF tried a wide range of solutions to use those logs. The first of it was to have Perl shells, Unix shells, to centralize, to manipulate those logs, and it was awfully hard to maintain. It did the job, but it was impossible to maintain. They also tried to have the log centralized into a relational database, which was a huge error because it was very difficult to scale, very difficult to exploit. It was a nightmare. And last but not least, they tried to rely on specialized material, specialized servers, big servers. It did the job, but it was really awfully expensive. So we took the decision to, as the French do that very well, we tried to copy the Americans. So we look at what Google and Facebook did. And they had a really simple idea, which is to explode the amount of data into small pieces and use local storage and local processor to process the data and store them, and then replicate this model to infinity to scale. So we looked into distributed computing. And distributed computing is hard because you have to code lots and lots of class, especially in Java, to make distributed computed. But hopefully we have Hadoop. Hadoop is done for abstracting the difficulty of distributed computing. But when you choose Hadoop, you do not choose, you do not have enough to process your logs. So we had to build a full architecture, a full data pipeline to process the log from where they are produced, meaning the application server, to where they are used, meaning dashboarding aggregation application. But I already talked about this architecture in Devoxx, in France, sorry. And you can find it on Parlez, in French, sorry again. But today we'll focus on what's happening to the data into Hadoop.
So during the last few days, you might possibly have heard about Java, about the future of Java, Java 8, the Stream API, on what will be next map on reduce on the JDK. It's important to know that so there is something called on Hadoop, which is Hadoop MapReduce. So they have the same word, so map on reduce, because they have the same origin. But really, when we are talking about Hadoop MapReduce, it's really a particular use case of MapReduce, which is really specific to Hadoop. So there is a few points to know. The first one is about what kind of data is manipulated by Hadoop MapReduce. So there won't be any kind of data that will be always a record. One record is always per key on a value. So the input of the map, the output of the map, the input of the reduce, and the output of the reduce will always be a record, so a key on a value. The key on the value can really be anything, but you have to really understand that it's always a record. The reason for that is that because it's due to the way Hadoop MapReduce is implemented. So we often talk about Hadoop MapReduce as MapReduce, but in fact it's map. Then there is a somewhat hidden operation that we officially called shuffle and sort, and then there is a reduce. The shuffle and sort, it's not usually talked about because there is a lot of technical details, but you can translate it as a group by operation. The idea is that the output of the map method will be a record, so a key on a value. Then before transferring this record to the reduce method, there will be a group by. In fact, we will group every record from the map method by their key. And so we will have one group by key, and one reduce method will handle only one group at a time. So it's really a very particular use case of MapReduce. You really have to understand that even if we are talking about MapReduce, it's more like map, group by, and then reduce. And then the last point is about the use of Hadoop. So map and reduce, you could use it for everything, but when we are talking about Hadoop MapReduce, we are really talking about a solution for doing distributed batch computing, which means it's not meant to have a low latency. The idea is really to be able to handle, to be able to process a large amount of data quick. So that's like any batch solution. You are able to process quickly a large amount of data, but you're not able to quickly process a small amount of data. And then for Hadoop MapReduce, we are speaking about distributed batch. So you have to know that the latency for Hadoop for a very small amount of data is something that you will notice in practice. So that was very high-level overview of what Hadoop MapReduce is. Then this is what the Hadoop MapReduce flow looks like. The idea is that the developer is only responsible for two things, providing the implementation of the map method, providing the implementation of the reduce method, and then everything else, everything which is in gray on the slide, is really up to the MapReduce framework. So the developer will say, I want to process this kind of data, and this data will be on the Hadoop cluster, but then everything else is managed by Hadoop MapReduce. So Hadoop MapReduce will find where the data is, how this data can be split into different input split. For each input split, you will try to execute the processing of this data in the same node. So that way, instead of moving the data to the computation, we will really perform the processing exactly on the same machine. So the only network which is used by the Hadoop MapReduce is really the bandwidth between the hard drive and CPU and on the network of the whole cluster. So that's the first step, being able to schedule and manage all these map tasks. So each task will be a different JVM on the cluster. And then the responsibility of the framework will be to transfer the data from the map task to the reduce. There we do the shuffle and sort, which is mainly a group by, a distributed group by. Then it will schedule the reduce. And then at the end, we have the final result, which will be stored again on the Hadoop cluster. And all the temporary information between map and reduce is only information that you have during the job, and at the end of the job, that's something that is deleted. So that's really the high-level overview of really how MapReduce works. Now we will see quite a simple example. So maybe you won't be able to see everything because the words are quite small. But the idea, when you want to learn any kind of framework, I mean almost any kind of framework, the first exercise would be to print hello world to almost everything, a console, a web page, or so on. You have to remember that Hadoop is really about data processing, so it doesn't make sense. And that's why the first exercise you do on Hadoop is really about word count. So that's what we will see now. You could ask yourself, and you can ask us, why we are speaking about word count. So in fact, that's not the kind of job that we were using at VSCT. But you have to understand that what we did was a bit more complex, so it wouldn't make sense to explain it now during a small conference. And the second point is that once you really understand how word count works, every MapReduce job is only a small variation of the job. So once you really got this example, you're able to use Hadoop to do whatever you want. So the idea of the job is that the input part will be, you can't really see, but there will be a list of documents, which means a list of text files. Each text file can be seen as a list of lines, and each line is a list of words. And what we want to have at the end of the job is what you can see on the right side of the slide, which is how many times I do observe one word in particular. So you might not be able to read every word, but second line you can see there is devox on that. There is 2 times devox in the input data, so first line and last line. So the way this whole job will work is first, MapReduce is responsible for splitting the data. So here we will have the record will be 1 line at a time. So we'll have the splitting at this level. That's really a high-level overview. You need to understand that you will have one call to the map method for each line. But if you are looking about the JVM side, one JVM will handle many lines, and potentially you will have many JVM that will handle the whole data set. But you have to understand that MapReduce is the one that will do the splitting and say how many JVM you need and where they should be started. Then the aim of the map part of this job will be to split the data. So we have a single line, and for each word on this line, there will be a record in the output of the map method, which will be the word, and then a 1 to say, well, I did observe this word once. So that's really the map. First, then there is the hidden operation, which is called shuffle and sort, but which is really a group by operation, which means that for each word we will have a distinct group, and for each group we will have all records which are related to this word. So I was speaking earlier about devox, and so we have 2 times this word in the input set, and we can see there is a group with these 2 records. And then For each group, we will have a call to the reduce method. And basically, what does the reduce method is only finding out the size of the group and outputting this. So for devox, we have 2 times devox. And then once all the reducers are done, we have the final results. And once again there, we have quite a simple overview of what Hadoop mappages works. But you can have multiple JVM that will do the reduce if you need to handle a large amount of data.
Okay, enough theory. Let's go back to the project. So, early 2010, we have our Hadoop cluster. We have the data inside the cluster. Now it's time to process them. So we have to choose a way of processing them. So we went for the pragmatic method. Hadoop is written in Java. I know how to handle Java. It ships with a Java native API. So let's go for it. At the time of the project, the native API was the most mature of it, and it was well documented, so let's do some code. As Bertrand said, as a developer, you have to write two classes, a mapper and a reducer. Here is a simple mapper for the word count. You can see that you have only one method, which is a method map. You extend Hadoop framework class, which is a mapper. The treatment into the method is really simple. Each line comes one by one. You split them, and you forward them to the next level, which is a reducer. You use what is called context here, which is let's say a shared bag of data. So you put everything in the context, and the Hadoop framework ships it to the next level. What you can also notice is that the method parameters here in blue are kind of specials. As Bertrand said, each step of a MapReduce jobs runs into a separate JVM. So between each steps, you have to serialize and deserialize your data because they are transferred on the network into another machine. On the same machine, you don't know. You don't pilot that part. So you have to write classes that are serializable, and Hadoop ships, the native API ships with classes to handle row types. Let's say long, ints, double. The text one handles strings. So everything should implement writable. So we have done the map part. We took the line, we split it into different words, and we ship it to the next level. In a real life project, everything is more or less the same. When you have a log line, the first thing you try to do is to isolate the information you want to keep. Let's say you want to do an overview of the response time of your system. So you will try to isolate the method name. You will try to isolate a time counter. And then you ship it to the next level. The next level is the reducer. As for the mapper, you extend a special class, which is a reducer. And there, in the method parameter, you see that you get the key. So in the word count, for example, you get the word devox. And you've got a list of an iterable, which is basically a list. And you'll get all the one we saw. For each word, you get one. So you just have to iterate over these ints and sum them up. Then once again, you use the context to write your results, and Hadoop will process them to the next step, the next step is writing the result on the disk, on the edge, and on the cluster. But in more complex world, you could have to ship your computed data to another MapReduce job. So what is cool about the native API? It's Java, cool. I think there is a Scala talk in the meanwhile, so I do not take much risks. So it's Java, so you have everything that comes with Java. You have cool developer tools. You can write your scripts in Eclipse, in IntelliJ. You can have access to all the tooling, the debugger, external libraries. You are able to perform unit tests using the MR unit framework. But those unit tests we'll talk later about. They are really basic. Saying you ship a line, you say, okay, do the map part, and you compare the result. Do the reduce part, and you compare the result. But you cannot use large files and process complex operations. You can use your favorite dependencies builder, Maven, Gradle, whatsoever. And you have also all the cool release tooling things with your Jenkins, your continuous integrations, your automated deployment scripts, and so on. So this is really great. We do, at VSCT, we did a prototype phase, and it was very convincing. And we had the green light to go to the next level. And I developed with the native API for about 6 months, even more. And that's when things get ugly. So the ugly part. First is Java. Okay, so you have all the Java drawbacks you can think of. But let's be honest, it's okay. I can cope with that because I cope with that every day on other projects. I know what the limitations are, and okay, I can deal with it. But the main part is that humans do not think in the MapReduce way. It's easy for a machine to split up operations and scale them to millions and millions of cores, but for a human being, it's difficult to split up a large amount of data within global. So we would like to say, okay, take this and do this with that. But it's difficult to think the MapReduce way. And maybe it's the more difficult thing you'll have to deal with when you start a Hadoop project. You say, oh, okay, I can do Java, so I can do MapReduce. That's not true. You can do the word count, but you cannot do more complex things without thinking ahead. What I showed you is simple mapper and reducer code, but there is lots and lots of boilerplates in Java, because once you have mapper and reducer, you have to glue them with a job configuration class. If you want to ship a complex object between the mapper and the reducer, or even between two MapReduce jobs, you have to implement the writable interface. You have to tell how the data are serialized, deserialized. You have to tell how the data are compared, because you have a sorting phase and so on. If you want to sort data, it's really complex because all the code runs on different JVMs. So how do you sort data? You have to pile them up into one reducer, but you will go into out-of-memory errors and so on. So it's really complex. Why is that? Because the native API is really a low-level API. You have to tell every machine what it should really do. When you think of big data and use cases, you'd rather say it like you explain it to a human being. Okay, take this file, split it into simple words, sum them up, and then write them in another place. And even more, you want to be able to empower your marketing people, the man who's giving order to say, okay, you too can deal with the data. Let's be creative. I give you the access to the cluster, and you have to think of it. Find me usages, and you cannot do it the Java way. So that's where we were. In 2010, when Bertrand joined the project, we had a full amount of native API, ugly, messy code, and he joined the project with the aim to have a more industrial face and to open the cluster to new people.
So what you have to remember is that Hadoop MapReduce is really a first abstraction. That's a very good abstraction because at no point the developer need to specify how many nodes he want to use in the cluster or how he should handle the failure case. So that's the first good abstraction, but that's only the first abstraction. When you want to do some kind of query which is not which is a bit more complex than the word count. Usually you won't do a single job, but you will do many jobs. So the complexity is to be able to first be able to think in terms of map and radius, but be able to say, well, I got a document. The document say I have this kind of information as input, and I need to produce this kind of metrics as output. On how many jobs do I need to do to implement to do that? Which jobs should I start first? When should I do a join between different outputs and so on? So that's really the hard issue about Hadoop MapReduce. It's that it's a first abstraction, but the abstraction in itself is not the good one for the end users. So that's a problematic which is well known in the Hadoop ecosystem, and that's why there is two projects which are well known to solve this issue that we will present just now. So one is Hive and one is Pig, and the way they work is really quite similar. The idea is that instead of directly implementing yourself the mapper and the reducer, you will express your query in a specific language. Then this query will be translated into a kind of logical plan, which means I need to do this kind of operation and this one and this one. So that's only how that represents only the logical flow of your data. And then that will be the responsibility of the tool to do the translation between this logical plan of execution and into a graph of map-reduce jobs. So that between the Hive and Pig logo, you can see one simple example of that. Maybe you have a query that can be expressed with 4 jobs, and you need to be aware that first you need to execute one job, that during the same time you can execute a second one, but if you want to continue, you need to wait for the first one to finish, execute the second one, and then when the second and the third one are finished, you can do a join, and then execute the last MapReduce jobs. So you really have to understand that if you want to do all that in Java, that's quite complex, even though the query you want to do might not be that complex. So that's why we looked first at Hive and Pig, because there are components of the Apache ecosystem which are well known to solve this issue. So we'll see the word count example for Hive and for Pig. The main difference between Hive and Pig is that they are not been done by the same company. So Hive is, I think, Facebook, and Pig is Yahoo. And the idea of Hive is really close to SQL, so we'll see an example soon. And Pig is really a custom language which is called Pig Latin, and same, we'll see the word count with Pig later. So that's how word count in Hive looks like. The idea is that it's really very close to SQL. So in SQL, you have 2 parts in the language. You have the data DML, data modification language, which is all about requesting the data, manipulating them, and then you have the DDL, data definition language, which is all about defining the schema and to say where and how the data is stored. So for Hive, you will have those concepts. So that's why when you're starting to write a word count for Hive, the first thing you need to do is define a table. So the table, the statement for creating the table is a classical SQL statement. So of course, behind the hood, that won't be a classical relational table. That will be merely an alias saying I know that I have data somewhere which have this kind of schema. And here the schema is only saying that the table my input is composed of a line, and that each line is only a string. The second operation will be to load data into this table. So really this table is only a view of what is stored on the Hadoop cluster. So the Hadoop cluster is only storing files. And what you do first for populating this table is that you say, I do have data into my local file system, so I want to load that into this table, and that's what does the second statement. So that's quite classical. The load data local may not be a standard SQL, but that's not a big surprise in itself. So that's really for setting up the data set, being able to say, I want to process this data, which this schema, and so on. And then the word count example is really what you can see at the end of the slide. So you have to remember that SQL is really a declarative way of saying how you will process your data, and it's you work bottom to up. So first you want to store the result. That's why you will create a specific table to store the result. That's what you can see at the first line, the create table word count as. And then you want to express what you want as a result. So there will be select word and count, because we are really interested in knowing the number of records per word. As a classical SQL statement, select statement, we will do a group by word, because we really want the count per word. So that's why we selected word and count in the select, the header of the select statement. So that's the first part, but that's actually the bottom of the workflow. And you can't actually directly manipulate the my input, because my input is only a list of lines. So you need to create another select statement that will act as a proxy between the my input and this query, and that's what you can see in bold. So that's not, once again, the operations are not might not be classical SQL, but the statement in itself is quite classical. So it's a select. Then you will do some kind of operation on the row, which is in the my input table, and then you say, I want to really read the data which is in my input. So that there, what we do is that we take each line, we split the line, so we have a list of words, and then we exclude this list of words. That way, instead of having only one line with a list of words, we do have n line, and each line has only one word, and then this result can be used by the top select statement to have the final result that will be stored in the word count table. So that's really quite easy to understand if you have any knowledge of SQL, and that's really the advantage of Hive. The main reason is that Java is a cool language, and that's why we are all here today. But actually, we have many data analysts that do not know Java. But if a data analyst need to know a language, the first language that he needs to know is obviously SQL, because there is a lot of relational database, and we have lots of data which are stored in a relational database. So once you have Hive installed on a machine somewhere, you can use SQL way to process the data on your Hadoop cluster. So that's really a first point, which is really interesting about Hive. The second is about what we call the metastore. So I really talk about the way Hive defines the schema of the data. So it's really like a standard relational database. You do have to create tables, but those tables are only a way to express where the data is stored and what is the schema of this data. all these definitions are stored in something which is called the metastore. There's a lot of NoSQL projects who say it's cool to have data and it's cool to not have any schema, so you can put everything inside this solution and then you can do everything you can. But in fact, when you want to analyze data, it's really useful to have a schema because you really want to know what this data is about. And what the Hive metastore provides you is a common place where you can share with everybody the definition of your table. So that's a good point about Hive, and that's something that you won't find for the other project in the Hadoop ecosystem. And that's something which is well known. That's why there is also another project which is called Hash Catalog, which aims at providing a public interface to the metastore. That way, if you are using the basic Java API, for example, for MapReduce, you could also use the table definition of Hive. So that's the second point. And the last point is that since we are using SQL as the language between the Hadoop cluster and the final user, you don't really need to have a user that is really manipulating the SQL language directly. You could have any tools that know how to speak SQL that will be using Hive as a kind of proxy between this tool and the Hadoop cluster. So Tableau is one example of this tool where you can do a data visualization. And Tableau is not really aware that you are processing data on Hadoop. The only thing is that he's doing SQL and he's talking to someone, and that someone is able to do something with this SQL query. So that was really the good part about Hive. Of course, there is not only the good side about Hive. The first one is about the complexity of SQL statement. So you have to remember that a declarative way of saying what you want, it's on its bottom up. So when you have only a single select statement, it's quite easy to say what you want to do. But once you're starting to do many nested select statements, it can become quite complex. So during the word count example, we have seen an example with two nested select statements. You can have many select statements, and then it's quite hard to be able to write it and also be able to maintain it. And there is no real tool in SQL to do that. The only thing you can do is to extract the nested select statement, to insert the data from this nested statement into a table that you have to define yourself, and then instead of querying this statement, querying the table. But then it's up to you to really define the table, to manage the life cycle of the data, and so on. So you have to understand that if you really have to do complex data processing with SQL, it might become indeed quite complex, and there is no tool to fix that. Second point is about the operation in Hive. So you have standard operations which are already provided by Hive, like split and count and so on. But you can provide your own operation. So that's something you do with what we call user-defined function. The issue there is that well, you can use several languages for defining the UDF, but that's mainly Java, or at least it's always a programming language. So that on one side, you will really program your query. You will use SQL to say, yes, I want to select this and this from this table. On the other side, you will have to work on the Java side, saying, oh, really, I need to have this function which takes this and this parameter and do this and this and this. And what you have to see that we are manipulating at the same time two languages which are quite different. And that's an issue in itself because that's hard to reason easily about both languages at the same time. So that's an issue about Hive. The third issue is about the testability of the SQL script. So mainly it's the same strategy as with a relational database. The only way to test the script you have written is to run them. But you have to be aware that we are not speaking about a relational database. We are speaking about Hadoop cluster. So when you're running a single Hadoop MapReduce job, even if it's only on one file with one line, it may take 10 seconds only because there is a lot of override. And when you're doing a SQL Hive query, the Hive query could be transformed into maybe 10 Hadoop MapReduce jobs. So even if you run a single SQL script, it may take 1 minute to execute. So if you have many SQL scripts, only for being able to run all those scripts, it can take a long time, and that's quite an issue in itself. And there is no solution yet for that either. So I talk about SQL. So of course, Hive is not fully SQL compliant. So first, it's only about the version 92 of SQL, and that's not the full SQL which is implemented. That's only the part which are relevant about Hadoop. You have to know that Hadoop is only storing immutable file on its file system. So you can't, for example, insert a line or delete a line from a table because there is no sense in doing so in a Hadoop cluster. And then there is a multiple way of working with Hive about the table definition. If you are really starting from scratch with Hive, it's quite easy because Hive provide everything to manage the file in your place. But if you have something which is already stored on a Hadoop cluster, the way you already have stored the file on the Hadoop cluster may not be fully compliant with the way Hive sees things. So you have many options, but you have to be aware that maybe if you want to use Hive with some file which has already been stored on the HDFS, you might need to change how the files are stored into HDFS. And this is also an issue because you have to be aware that there is a change to be done, and you have to potentially to impact other applications, so that's not trivial necessarily every time. So this was about Hive. Now I will speak about Pig. So you have to remember that they try to solve the same issue. So we really will express the query with a high-level language, and then that will be the tool, so Hive or Pig, that will translate this query into a graph of my pages job. And that's how looks the word count in Pig. So it might not be so easy as Hive because it's quite a new language. That's a language which is called Pig Latin. But if you have already worked with any kind of ETL tools, that's the kind of operation, the level of abstraction which you are used to work with. So you really have to understand that each statement is not a statement which should be executed at each time, but it's only a way to express how your logical plan will be formed. So the first line will be about loading the data, and then it's quite a procedural way of saying things. So that's quite classical. If you want to do a word count, the first thing you need to do is to tokenize the line. So that's what we can see with the tokenize, the first parameter of the lines which were provided as input. And then we have the flatten, which is the same thing as with Hive. Instead of having a line with lots of words, we'll have one line with at each time only one word. And then we do a group by each word. And then for each group, we will count the number of words. So there you can see we have a for each group generate count and group. And group is actually the key of the group by. We are saying there that we want to have the count of words which are related to a specific word. And then at the end, we can store this result into a file. And at this moment, when you are executing this script, Pig will know the whole logical plan of operation you want to do, and then at this point he's able to say, oh, I know that I can execute that in maybe 1, 2, or 3 jobs, and he will do that for you. So the good part is there is no technical requirement. So for Hive, you had to learn SQL. For the basic Java API, you have to learn Java. Here, if you have any experience with any kind of scripting language, you can use Pig. As we have seen, it's really a procedural way of saying things. That's a good aspect of Pig because when we speak about any kind of data processing, we tend to speak in a procedural way. We say, oh, I do this thing, and then I will do that, and then this one, I will store the intermediary result somewhere, and then I will do something, and I will retrieve again the result, and so on. So that's really the way we tend to things. So that's a good way that the language is really close to the way we tend to see things. And of course, that's only a script. With Java, you might need to use an IDE. For Pig, you can use whatever you want. If you want to use VI, you can use VI to write your own Pig script. So that was the good part of Pig. Of course, there is not everything which is good about Pig. The first one is clearly that's a new language. So it might not be that complex, but you can't simply say to someone who doesn't know Pig Latin, you have to write a script and do it now. There is a few things to learn to how to write the language and how to debug it and so on. Just like with Hive, there is an issue about how do I test my script, because there is no way of testing the script except by running them into a cluster. And that means that even for a simple script, you can take 1 minute to execute the script, even if there is only a very small amount of data. If you have one script, you will have many scripts in a real project. So only running maybe 10 or 20 scripts can take a few minutes, or can take maybe up to half an hour. So that's really one issue. Third point is about automatic retry and failure. You really have to understand that what does Pig and Hive under the hood is to build a graph of MapReduce jobs. So that's nice because MapReduce is able to handle failure for each job. So if you lose a map task or if you lose a reduce task, MapReduce is able to handle that. But if you have done all the processing for all your graph, but the last job failed, you have to start over, and there is no support for trying only to start again the last job. And last point, it's hard to debug. It's only a script, and there is no real tool for doing so. So this was about Pig and Hive. Pig and Hive are really the projects which are the most well-known in the Apache ecosystem for Hadoop. Now we'll talk about Cascading, which is less known, but which was more relevant to us. The idea is that Cascading is working on the same level as Pig and Hive. That is, you will have to specify your processing as a kind of logical flow. That's what you can see at the top of the slide. So we have a different operation, like iterating over each tuple, then doing a join, and so on. So you have your execution plan, and that will be the responsibility of Cascading to transform this execution plan into a set of MapReduce jobs. So that's what you can see there. So that's really the same responsibility as Hive and Pig. The main advantage of Cascading will be that instead of be a new language, be it SQL or Pig Latin, Cascading will only be a new API in Java. So here you can see the word count in Cascading. So it's quite more verbose than what we have seen with SQL and with Pig Latin. But what is really interesting is the third part of the slide. So this one, that's where we are defining the pipe. So really the data flow, where the data will be manipulated. So that's really the same. The logic is the same as what we have seen with Pig. The first one will be to split the line into a set of words, and then we'll regroup by the word, and then we will count the size of each group. So that will be the same. What's interesting about Cascading is that there we have the definition of a pipe, and then we have a definition of what we call flow definition. And then you have really two different concepts. On one side, you have the data flow. On the second side, you have how you bind this data flow to specific data set. And the data set in Cascading are called type. So here we have, so the first one I think is the input tab, and the second one is the output tab. So that's only a way of specifying where I am reading data and where I am writing data. So the main advantage of Cascading is that we are back to Java. So that's that was a great advantage for us because we are used to manipulate Java daily. If you don't want to work with Java, you have to understand that Cascading is only a Java API. So there are other projects which are working on top of Cascading. So if you like Scala, there is something called Scalding. If you like Clojure, there is something called Cascalog. And if you really like SQL, there also is something which is called Lingual. There was a presentation maybe yesterday about that. really the abstraction which is used by Cascading is really the same as Pig. So once again, we are working with a procedural way of seeing things, and that's quite natural, and that's a good thing about the way we will work with Cascading. The third point is about advanced unit testing, and that's actually the issue we had with Pig and Hive. So the issue with Pig and Hives is that there is no easy way to do a full test of all the Pig script of the Pig or the SQL Hive script. The advantage of Cascading is that we really have two concepts. There is a data flow, and there is really what we call the pipe. And the advantage of Cascading is that Hadoop is not the only platform which can be targeted by Cascading. There is also a second platform, which is an in-memory platform. So that's not a platform which is recommended to use in production. It's only for use for testing, but it means you can run a complex Cascading query only using this platform, and this query can run in maybe 1 or 2 milliseconds. And so you really have great advantage with regard to Hive and Pig. That's Cascading provides you with a very simple way of testing a bunch of complex query on top of Hadoop. And then about debugging dependencies on release, that's the same statement as with the Java API. You know how to do it with a Java application, and there's really no surprise there. You can put a debug point in any IDE. You can handle dependencies with tools like Maven, and you can do a release with Maven, Hudson, Jenkins, and so on. And once again, the main advantage of Cascading is that we really have an API that we can manipulate ourselves. So it's quite easy to say, I want to process data that way, and then applying this data flow either on Hadoop for dealing with big data, or either fully in memory, and that way we can verify that the data flow is correct, even if we are dealing only with a small amount of data. So obviously, not everything is good with Cascading. So first, there is a learning curve. So you don't know Hadoop, you have to, it's still a good idea to learn about Hadoop MapReduce, but you have to learn about another framework. Debugging is not trivial. That's something which is true for every kind of solution which is based on Hadoop MapReduce. You have to understand that you have something which will translate your query into a set of MapReduce jobs. So there is really something complex there, and that's why debugging is not trivial. One bad point about Cascading will be that the API is quite verbose. So that's what we've seen with the example. If you want to apply a simple function for every record of the input, you have to provide a list of the named parameters, and you have to provide a list of the name of the output on the function also. So that's quite verbose, and that's why you have a project like Cascading and Cascaloid for solving that kind of issue. And the last point is about the optimizer. So that's a good point and a bad point. That depends how you see things. But the optimizer of Cascading is quite simpler than the one of Pig and Hive. The advantage is that when you have a translation of your query, that will be always the same. So if you're handling 1 gigabyte of data or 100 gigabyte of data, you won't have a surprise about the translation. But with Pig and Hive are able to do clever tricks about, I know that I am dealing with that amount of data, so maybe this strategy is more appropriate for this kind of solution. Cascading does not do that, so that's a bad side, because in terms of performance, you really have to understand what you do, but that's a good side because you have a kind of predictability of what will happen on your cluster. So that's the last project we use at VSCT.
Okay, so let's wrap it up. We showed you 4 different ways to manipulate your data in Hadoop. What is the situation now at Voyage NCF? As you may have feel it, we are very convinced that Cascading is the solution for Java developers to manipulate data, because it's Java, you have everything you want to test. So we rewrote all my crappy native API scripts into Cascading. We still have a few native API scripts that are leftovers. And we left aside Hive and Pig, not because we think that they are bad tools, but we wanted to use them to open the MapReduce world to other kind of people. And we missed the target, not because of the tool, but because of the lack of time and investment and leadership you can find in your marketing teams. The learning curve is not trivial, so it's difficult to open your cluster. So we stayed with the Java team, and we migrate everything into Cascading. So what's happening next? We talked almost about batch. And we know that time is the key to handle the data. So there is a few projects that are competing now to go for real-time big data analytics. On one side, you have Apache Drill and Cloudera Impala that are trying to bring the SQL-like querying into real time. You have another project called Storm, which is more an event processing engine. And then you have Spark, which is also an Apache project, which runs on top of Hadoop, which aim to do MapReduce in memory, so lightning fast MapReduces. And what we see coming is that maybe the answer is not only batch or only real-time, but what the buzzword is Lambda architecture, that you have one side of your architecture dedicated to batch, and I think that on this side, Hadoop has won the battle. And you will process your data the batch way. And then you have what's happened to your system in real time. How do you handle the data? And this side is not clear, actually. So we are already trying to implement some of these tools at VSCT to go aside Hadoop or even to replace it in some time. So the future is uncertain, but what we know is that it's coming. Thank you for your attention. We have very few time for the questions. Sorry about that. Is there any questions? No?
Yes.
Yeah. Yeah, the question is there a sense to use Hive with cascading?
So maybe there is a few ways of seeing things. So first, if you really want to use SQL, there is something which is called lingual, which is a SQL on top of cascading. So that's one way you could have something like Hive, but which is not Hive. Then the second part of the answer is about hash catalog. So as far as I know, there is no, well, it is not widely used bridge to use hash catalog from cascading. So you could use Hive on cascading, but they will be working not together.
Anyone else? We have still 2 minutes. Okay, here. Sorry, speak loud. The question is, did we consider to use Crunch instead of cascading? No, by lack of time. Bertrand was already coming on the project with a good knowledge of cascading. And once I saw the power of it, I went for it. So we already learned native API, Hive, Pig, cascading. So it's a bit complicated to add a new language, but it could be interesting in some ways, yeah.
They're very similar.
Yeah.
But cascading is quite older. They might solve the same problem differently, maybe, but cascading is quite older, so you have a big community around cascading. which you might not have about Crunch. I don't know much about Crunch, but that's one point to know.
Okay, thank you for your time.